Hello dear students, today we will discuss Newton forward method in interpolation chapter. So let us start from definition. This is introductory part of the basic idea about interpolation. So first of all we will discuss what is interpolation. Suppose let y equal to fx be a given function of x. Then suppose the value of y for a set of argument x0 to xn are given as follow. Suppose this is the interpolation form: x is x0, x1, x2 dot 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 up to xn, and the value of y is, we have already discussed what is the value of x. X is argument and y is their entries. So y equal to y0. Y0 means f of x0. When putting x equal to 0 in fx, then it becomes y0 equal to f of x0. Similarly, when we put the value of x equal to x1 in fx, then it becomes y1 equal to f1, and x2, then it becomes y2 equal to fx2 dot 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 xn, then yn equal to fxn. Now the process of finding the values of the corresponding to any value of x equal to x1. Suppose we have to evaluate the value of like x7 between x0 to xn. Then this process for finding the value of x7 is called interpolation. Means here we just take the generalized value x equal to xi. The process of finding x equal to xi between x0 to xn is known as interpolation. So interpolation is clear. We have the argument x0 to xn. Suppose we have to find any values in between x0 to xn, then this process of finding the value between x0 to xn is known as interpolation. Now in the sequence of interpolation, there are the following types of interpolation. The first, in group A, for equal intervals. There are two groups of interpolation. In first group, when we have the equal intervals. In terms of equal intervals, the first type is Newton forward difference formula. The second is Newton backward difference formula, and third is central difference formula. These three are the method for finding the interpolation when we have the equal intervals. Now in second group, group B, for unequal intervals, there are two methods for unequal intervals, that is Lagrange's interpolation formula, and next is fifth is Newton's interpolation formula. So there are 5 types of interpolations. Some interpolations are for equal intervals and some are unequal intervals. These three methods, Newton forward difference formula, Newton backward difference formula, and third is central difference formula. These three are for equal intervals, and rest of two methods are for finding unequal intervals. So let us start from type 1, that is Newton forward difference interpolation formula. As I have discussed, this is equal intervals formula. So the Newton forward difference formula, interpolation formula, is y equal to fx equal to y0 plus u of del of y0 plus u minus 1 divided by factorial 2 del square y0 plus u minus 1 u minus 2 divided by factorial 3 del cube y0 plus dot dot dot. So what is the value of u? U is x minus x0 divided by h, where u equal to x minus x0 divided by h. We can write x equal to x0 plus uh when multiplying this cross multiplication, and the value of x is x0 plus uh. So the Newton forward difference formula is y equal to fx equal to y0 plus u of del y0 plus u minus 1 divided by factorial 2 del squared y0 plus u minus 1 u minus 2 divided by factorial 3 del cube y0. So this del is known as forward notations. Now see in problems. Problem 1. Find the polynomial which fits the data in the following table. Here is the table. X equal to 3, 5, 7, 9, 11. See here it has equal intervals. 3 plus 2, it becomes 5. 5 plus 2, that is 7. 7 plus 2, that is 9. 9 plus 2 is 11. That means in each group have equal intervals. And the value of y is 6, 24, 20, 58, 104, 174. Also find F2 and F4. So this is the problems regarding Newton's forward difference interpolation formula. Find the polynomial which fits of data in the following table. This is the table, and we have to find F2 and F4 with the help of Newton forward interpolation formula. Now see the solution of this problem. First of all, we put the given data, that is x equal to 3, 5, 7, 9, 11, and here y equal to 6, 24, 58, 108 and 174. First value of y is known as y0, that is initial value of y, that is 6. Now in headed, that is del y, del square y, del cube y and del 4y, del fib y as per the question requirement. So this is given, the value of x table is given, y table is given. Now first we derive table number 3rd, that is del y. How can we derive the del y? Del y is difference between these two. See 24 minus 6. I have indicated by arrow. 24 minus 6, that is 18. Next 58 minus 24 and write down in middle, that is 34. Next 108 minus 58, and the difference between these two write down in middle, that is 50. 174 minus 108, I have indicated by arrow and put in middle, that is 66. Again indicate del y 0. Del y 0 means initial value of del y is 18. So write down here the value is del y 0, that is 18. Again repeat the same process in del square y, means difference between these two, 34 minus 18, and put in the middle, that is 16. Again 50 minus 34, it becomes again 16. 66 minus 50, put in middle, that is 16. So this is the del square y0, first value of This is known as del square y0. Again, difference between these two is 0. Difference between these two again 0. That is del square y0. The first value is del square y0. And again the difference between these two in the next differences, again it becomes 0. So the del to the power 4 y0. So here is del, here is y0, then del y0, then del square y0, del cube y0, del 4 y0. The first value like this: 6, 18, 16, 0 and 0. Now here from the table we see that x0 is 3. First initial value of x is known as x0 and x0 is 3. And what is the difference? Difference between these two: 5 minus 3, 7 minus 5, 9 minus 7, 11 minus 9. This is h. H is the interval. And how can we find the interval difference between the values of x? So here the difference are equal. So that's why the problem of Newton forward method is for equal intervals problems. So x equal to x as usual, u equal to x minus x0 divided by h. So x0 is here, x0 is 3, so it becomes u equal to x minus 3 divided by 2. H value is 2. Now using the formula of Newton's forward formula. What is Newton forward formula? Y equal to y equal to fx equal to y0 plus del of y0 plus u minus u of u minus 1 divided by factorial 2 del square y0 plus dot dot dot. So put here all the values from above table. Y0, first is y0, as I have indicated y0 is 6, so write down 6 plus u is x minus 3 divided by 2, so put here x minus 3 divided by 2. And del y0, what is del y0? Del y0 is 18, so here 18. U minus 1 divided by factorial 2, so put the value of u is x minus 3 divided by 2, and u minus 1 is x minus 3 divided by 2 minus 1. And what is factorial 2? Factorial 2 is written as 2 into 1. And then del square y is the first value, this one 16, so put here 16. And rest of the table becomes 0, so further steps will be 0. On simplification of these steps, first is 6, then is 9x minus 27, and after simplification of these parts, x minus 3, x minus 5 of 2. On solving and the result, it becomes 2x square minus 7x plus 9. So this is the polynomial of the result of the table fx equal to 2x square minus 7x plus 9. This is one part of the solution. And the next part of the solution is we have to find the value of f2. So put here in place of x2, we get the value of f2. F2 is 2 of 2 square minus 7 into 2 plus 9. It becomes 3. Now the next is f4. F4 means put here in place of x 4. It becomes 2 of 4 square minus 7 into 4 plus 9. And the solution is 13. So this is the method of Newton forward interpolation formula, and with the help of this formula we can evaluate all the values of Newton forward related results. Thank you.